Hey guys, Mr. Gretto here. I want to help you guys balance an equation that's had a huge impact on your life. It's known as the Haber-Bosch process. Alright, and basically what the Haber-Bosch process does is combine nitrogen gas with hydrogen gas to form ammonia. We'll talk about why that's important in a couple minutes. But first off, this process was developed around 1905 by a guy named Fritz Haber and his buddy Carl Bosch. Alright. Had kind of a dual impact on the human world, or human population. Developed 1905, right around World War I, and was a key component of giving Germany more ammonia to make bombs. So, originally Germany had their bomb source cut off. This process made it so that they could still make their bombs. Yikes. So it ended up causing about 100,000 deaths, just from more bombs and things like that, keeping Germany's war going on. On a brighter note, it's probably caused about 5 billion life or births since then. So ammonia is also a key ingredient in fertilizers, and back in the day, around World War I, our population was more towards like 2 billion range, 1.6 billion range. Tiny compared to our current 7.2 billion range. So it's helped us increase that ammonia, that fertilizer. Helped us increase our population by 5.5 billion people. Huge change. Alright. But enough of the history, let's go back to the chemistry. So, we want to try to balance this equation here. We'll take a look at it just with a whiteboard. To balance any equation, you do the same thing. You figure out how many of each element you have on the left, and you make sure you have the same amount of those elements on the right. So, I like to go left to right, just because that's how it's easiest for me. If I'm looking at this equation, I see N2 means I have 2 nitrogen. If I look over here on the right side, I only have 1 nitrogen. So I know I'll have to balance that later. I also see I have 2 hydrogens here and 3 hydrogens on the opposite side, the right side. So also unbalanced. So I have 2 things I definitely need to balance. Let's see how I could balance them. So what I always do is I figure out which side has the least, and I add more of that ever element or molecule needs to be on that side. So if I'm going left to right, I see nitrogen has 2, nitrogen has 1, so I need more nitrogens on the right side. So I'm definitely going to add more of that ammonia on the right side. So I can just go right here, go NH3. And now I've added my more ammonia. I have 2 nitrogens on the left side also, so the nitrogens are balanced. Perfect. Go to my next element. I see H2, 2 hydrogens. Over here at 3, 6 hydrogens. Right? So I need more hydrogens on the left side. So I have to balance that out. Let's see. If I add 1 more, I got 2, 4 hydrogens. Still not enough. I need 6. So I actually have to add 1 more. 2, 4, 6 hydrogens, 3, 6 hydrogens. Perfect. Now I'm actually balanced. This Haber-Bosch process has been balanced. So we double check our numbers just in case. I see 2 nitrogens, 1, 2, 6 hydrogens, 6 hydrogens, 3, 3. Perfect. All right. Now to finish off our equation, what we have to do is we have to add what's known as coefficients. So these little numbers are subscripts, represent 2 hydrogens. Coefficients represent how many molecules or elements we have. So if we're counting elements, we see, look over here, I only see that I have 1 N, so there's no other N2s over here. So I can just put an N1 nitrogen gas right there. Over here, I see 1, 2, 3 hydrogens, so I can plug a 3 in. Right there is my coefficient. And last but not least, I see 2 ammonias, so I can put a 2 there to represent my 2 molecules of ammonia. And these 3 numbers, 1, 3, and 2, are the important thing, our end goal for our balancing equations. There are coefficients that we want. All right. To learn more about Fritz Haber, check out Fritz Haber Great Minds by SciShow on YouTube.com. Alright crew, happy balancing. Catch you next time. To learn more about Fritz Haber, check out Fritz Haber Great Minds by SciShow on YouTube.com. Alright crew, happy balancing. Catch you next time.